Hello and welcome to the Daily AI Brief, your premier source for the latest in artificial intelligence innovations and breakthroughs. Today, we're diving deep into the newest developments shaping the world of AI. From game-changing models to advancements in cybersecurity, we've got you covered. Let's jump right in. Alibaba has entered the high-stakes AI arena with the launch of Qwen 3.8 Max, an AI model that's causing quite a stir in the tech community. Announced at the World Artificial Intelligence Conference in Shanghai, Qwen 3.8 Max is designed to take on major players like OpenAI and Anthropic. Alibaba's latest edition, boasting 2.4 trillion parameters and utilizing a mixture of experts' MoE architecture, represents a formidable player in the AI landscape. This setup allows the model to selectively activate parameters, which enhances computational efficiency and performance. For instance, in a large-scale machine learning task, a traditional model might process all parameters at once, leading to unnecessary computational load. In contrast, the MoE architecture enables Qwen 3.8 Max to use only the necessary parameters for a specific task, akin to a smart distribution of resources, thus optimizing computational power and reducing latency. The model's multimodal capabilities mean it can handle natural language processing, image analysis, and document processing, making it particularly suited for diverse enterprise applications. These functions could range from automating routine customer service inquiries to analyzing complex datasets in real time. The broad applicability aligns well with evolving technological trends, where enterprises crave versatile AI systems that can adapt to multiple roles across departments. Despite the hype, however, details about Qwen 3.8 Max are sparse. Key performance benchmarks have not been disclosed, leaving many questions about its actual ability to compete with rivals like Anthropic's Fable 5, to which Alibaba claims Qwen 3.8 Max is second. Transparency about licensing and availability of a model card, which typically details a model's specifications and performance metrics, further clouds its immediate usability. Such information is crucial for developers aiming to integrate the model with existing systems, ensuring compatibility and optimizing performance. The model is accessible via Alibaba's token plan and platforms like Coder and Coderwork at an appealing initial price point, just 1/10 of the standard cost. This low barrier to entry makes it enticing for enterprises looking to experiment without a massive financial commitment, especially as they weigh the benefits of upgrading their technological stack against budget constraints. However, the absence of benchmarks means potential users are flying somewhat blind. Without clear metrics, it's challenging to gauge how Qwen 3.8 Max holds up against established AI giants. Risks include the model potentially underperforming in real-world environments or enterprises grappling with licensing complications, which could lead to unforeseen operational hurdles. For those curious, trying the preview version through Alibaba's Coder platform is a smart step. This allows a hands-on experience to test the waters before full-scale implementation. Enterprises should also keep an eye on announcements regarding potential open-weight releases, which could significantly broaden the model's utility by allowing tailored customizations and optimizations. Qwen 3.8 Max is shaping up to be a big piece in Alibaba's strategy to cement itself as a key AI player, offering enterprises a tantalizing new tool in their tech arsenal. The model's success in the marketplace will depend heavily on Alibaba's ability to address transparency issues and provide competitive performance data. How it actually measures up against competitors and the impact on global AI dynamics will be the story to watch. Cogent AI has unveiled VR1, a cutting-edge cyber reasoning model poised to transform enterprise cybersecurity. Introduced on July 27, 2026, this model is designed to operate like a highly skilled adversary, autonomously mapping and identifying potential attack paths within enterprise systems. Central to VR1's functionality is the sophisticated AI reasoning engine. This component outperforms its predecessors by doubling the number of attack paths it can identify, a feat that sets a new benchmark in the field. Impressively, it achieves this heightened performance at roughly 25% of the cost of competing models, offering a financially viable solution for enterprises keen on enhancing their security measures without substantial financial strain. The model's seamless integration capabilities are facilitated by robust API support, allowing it to be deployed within existing security infrastructures smoothly. This adaptability ensures that VR1 can be utilized in complex enterprise environments without disrupting current systems. Backing its development, Cogent AI secured $42 million in Series A funding, reinforcing its commitment to cutting-edge innovations, which were further bolstered by a strategic partnership with Anthropic, enhancing the model's autonomic capabilities. Benchmark testing of VR1 utilized the intrusion bench framework, underscoring its superior capabilities in detecting and mapping attack paths. While these benchmarks highlight VR1's technical prowess, the lack of full transparency regarding specific methodological details raises questions about its applicability across varied real-world scenarios. This uncertainty emphasizes the need for thorough evaluations in diverse enterprise landscapes to confirm the model's efficacy. For organizations assessing the potential of VR1, viewing demos and case studies available on the Cogent AI platform is recommended. These resources allow enterprises to assess the model's performance against specific cybersecurity benchmarks, providing critical insights into its operational readiness and benefits. By introducing VR1, Cogent AI pushes the envelope in AI-driven security, shifting focus towards preemptive security strategies. The combination of the model's cost-effectiveness and sophisticated capabilities might significantly influence enterprise cybersecurity protocols. However, as these models become integral to cyber defense, ongoing validation in various environments will be paramount to ensure their effectiveness and reliability in addressing complex cybersecurity challenges. Thinking Machines Lab has just launched Inkling-Small, a sophisticated new multimodal mixture of experts (MoE) model, poised to revolutionize AI applications, particularly for startups and medium-sized businesses. Characterized by its impressive 276 billion parameters, with 12 billion active parameters per token, Inkling-Small marks a significant milestone in scalable AI technology. At the core of Inkling-Small is its MoE architecture, which effectively optimizes active parameters. This sophisticated design utilizes sparse activation strategies, activating only a subset of the model's parameters during task execution. Such efficiency reduces computational load and enhances task-specific performance without compromising on the depth or breadth of the model's capabilities. This is crucial for powering applications ranging from coding assistance to content generation, and it provides an expansive ability to process data types like text, images, audio, and video. Inkling-Small exhibits exceptional performance on industry benchmarks, achieving 46.6% on the HLE with tools and 88.3% on the GPQA Diamond benchmarks. However, the absence of published full-weight details presents a challenge for independent verification, suggesting a cautious approach towards absolute performance claims. The smaller sibling to the flagship Inkling model, which boasts 975 billion parameters, Inkling-Small presents a more accessible version designed to meet the specific needs of mid-sized enterprises. This accessibility is further enhanced by its open-weight framework, which allows developers to adapt and refine the model using the Tinker platform, encouraging customization and fostering innovation without the hefty price tag of licensing fees. Practically, developers seeking to customize and implement this model should begin by exploring the Tinker platform's documentation for step-by-step guidance. Commands such as git clone, model repo URL provide a practical starting point for engaging with the model. Inkling-Small's architecture not only facilitates innovation, but also helps democratize powerful AI tools, lowering barriers for diverse sectors including finance, healthcare, and more. Despite its promising capabilities, Inkling-Small does not claim to be the strongest model available, reflecting strategic trade-offs between size, efficiency, and performance across specialized tasks. The model's open-weight nature can lead to performance variability. Adaptations could result in inconsistent outcomes depending on user modifications. Yet, this design choice positions Inkling-Small as an intriguing option for enterprises aiming to integrate versatile and affordable AI solutions into their operations, while participating in a broader movement towards more accessible, community-driven AI development. Overall, Inkling-Small represents a blend of technical prowess and strategic accessibility. potentially influencing future AI designs by showcasing the viability of scalable, open-weight architectures in practical applications. Such innovation not only benefits users through immediate scalability gains, but also sets a precedent for future collaborative AI advancements. On March 16, 2026, NVIDIA ushered in a new era of AI-native data storage solutions with the launch of the BlueField-4 STX storage processor. Designed to cater to the burgeoning demands of AI workloads, this modular architecture promises to overhaul traditional data management by addressing specific inefficiencies inherent in conventional data centers. Central to its transformative potential is the BlueField-4 STX's leveraging of the NVIDIA Vera Rubin platform. It integrates a storage-optimized BlueField-4 processor optimized for AI applications. This integration facilitates unprecedented data transfer speeds, supporting throughput up to 800 gigabits per second, which translates into a doubling of data ingestion speeds compared to previous legacy setups. Such performance gains are crucial as enterprises shift towards AI-driven processes that require real-time data interaction and processing. One of the standout features is the architecture's token throughput, which is cited as being up to 5 times greater than that of traditional CPU-based systems. This improvement reflects NVIDIA's focus on developing systems that not only enhance processing speed, but do so with significant energy efficiency, 4 times greater than conventional models, presenting both a performance and environmental advantage. Security, a perennial concern in data management, is robustly addressed through NVIDIA's advanced measures, including Doka Vault, Argus, and Flow. These innovations provide high-speed, zero-trust data protection, an essential feature as data breaches and security threats become more sophisticated. Furthermore, the runtime threat detection capabilities operate 1,000 times faster than traditional agentless solutions, making it a comprehensive tool for modern enterprise security needs. Despite the promising capabilities, the BlueField-4 STX's effectiveness is contingent on independent validation of NVIDIA's performance claims. Such third-party assessments are crucial to verify these benchmarks across diverse operational ecosystems. Enterprises considering adoption must also evaluate potential integration challenges, particularly where existing infrastructures might conflict with this new architecture. Compatibility and seamless integration are vital to fully leverage the advantages offered by the BlueField-4 STX. For those interested in a deeper dive into the architecture's intricacies and potential applications, NVIDIA's official blog and detailed product pages offer invaluable insights. These resources elucidate the practical steps and technical specifics necessary to utilize the technology effectively. The introduction of the BlueField-4 STX could indeed redefine standards for AI-native storage solutions. Its alignment with growing AI demands indicates a potential decrease in operational costs and a significant acceleration in AI research and applications. By offering improved data processing capabilities and robust security protocols, it sets the stage for future innovations in enterprise-level AI storage. MiniMax recently unveiled its H3 model, a breakthrough in 2K video generation that includes advanced audio synchronization through a multimodal system. This sophisticated integration not only marks a significant advancement in multimedia content creation, but also positions MiniMax to influence the rapidly evolving landscape of AI-driven video technology. Building on the groundbreaking capabilities of the M3 model, which impressed with its 1 million token context window for complex content integration, the H3 model enhances the synergy between audio and video elements using advanced neural networks. These networks manage the complexity of combining video and audio inputs, ensuring high fidelity and continuity in generated content. The comprehensive API support ensures that developers can seamlessly integrate these features into their existing systems, paving the way for widespread adoption in high-quality video production workflows. However, the model's accessibility is currently limited due to the lack of open weights. This restriction may pose significant barriers to community-driven innovation and experimentation, critical for the widespread adoption of cutting-edge technologies. Despite this, MiniMax's token plan aims to mitigate some accessibility issues by offering a unified access framework for enterprise clients, promising a streamlined and efficient content generation process. Key performance metrics, such as latency and response times for video generation, have not yet been disclosed. Such metrics are crucial for developers to understand the resource intensity and operational efficiency of the H3 model, particularly when compared to alternative models like MMVIT and mplug2. These competitive models are known for their action recognition and multimodal capabilities, but offer differing performance dynamics and resource consumption levels. As developers await more comprehensive data, they can access MiniMax's extensive documentation to explore potential applications and prepare to leverage the forthcoming APIs to craft synchronized multimedia narratives. This opportunity provides a platform to test H3's capabilities in real-world scenarios, which is vital for understanding how the model performs under various creative demands and constraints. The implications of H3 achieving its ambitious goals are profound. Not only could it set new standards for media generation, fostering further industry investments, but it might also push the boundaries of technological integration. The dynamic competition in this field, illustrated by the performance and capabilities of models like MMVIT and mplug2, underscores the importance of continued innovation. Should H3 prove successful, it could lead to rapid advancements, not just within MiniMax's offerings, but across the entire AI-driven video generation industry. This evolving landscape will also prompt discussions on regulatory and ethical considerations as AI-generated content becomes more prevalent and complex. A recent report highlights a critical lapse in AI security as industries rapidly embrace AI technologies. Alarmingly, 78% of enterprises have fallen victim to AI-related security breaches, spurring a significant pause in AI deployments. This trend emphasizes the urgency for improved governance frameworks and security measures. Many of these security issues stem from inadequate identity verification and lax access management protocols, precipitating incidents such as unauthorized database deletions and compromised chatbots. The Commonwealth Bank of Australia's challenges with their chatbot highlight the repercussions of these oversights. A notable incident at Replit saw database deletion linked to rushed AI deployments, highlighting the severe risks of bypassing thorough security measures. To mitigate these threats, it is crucial for enterprises to implement strict access controls and identity verification processes. Continuous monitoring of AI agents can detect unauthorized actions, supporting a security-first AI strategy. In fact, studies indicate that comprehensive security testing before deployment can diminish vulnerabilities by at least 30%. Alongside technical measures, fostering comprehensive AI governance frameworks plays a crucial role in mitigating security risks. Organizations must adapt change management strategies to accommodate AI integration without compromising on security, as the complexity of AI systems can introduce unexpected vulnerabilities. Enterprises are encouraged to review TechTarget's detailed horror stories and establish governance structures tailored to their AI strategies, emphasizing security and compliance. This can serve as a preventative research exercise, aiding businesses in uncovering and addressing potential vulnerabilities in their AI ecosystem. As AI technologies continue to evolve, adapting security protocols to meet emerging threats remains vital. Organizations that delay bolstering their AI security frameworks may encounter significant financial and reputational setbacks. Therefore, it's imperative for companies to actively pursue robust defenses against the growing landscape of AI security threats. Strengthened training for personnel involved in AI deployments will equip them to handle potential challenges effectively, aligning with the proactive measures advocated by the UK's National Cybersecurity Centre. Onton has made a bold announcement with the theoretical release of Ontology 1, a neurosymbolic search model that claims to revolutionize product searches in e-commerce landscapes. However, a critical examination reveals an intriguing lack of corroboration from reputable sources, leaving the industry questioning whether Ontology 1 is truly ready for market deployment or remains merely a conceptual innovation. The foundation of Ontology 1 lies in its integration of neural networks with symbolic reasoning. This combination is designed to enhance search accuracy by mimicking the cognitive processes of human reasoning, allowing the system to interpret and connect disparate pieces of information more intelligently. This is especially crucial in e-commerce, where the diversity and variability of product listings are vast and ever-changing. One fascinating aspect of Ontology One is its supposed proficiency in operating effectively with limited datasets. Traditional search models often necessitate extensive databases to generate precise results, which can be a significant barrier for smaller enterprises. If Ontology One succeeds in minimizing this requirement, it could democratize technology by allowing broader access to sophisticated search capabilities, providing smaller players a competitive edge in the market. Despite these promising claims, Onton has not disclosed specific details about the APIs, methods, or architecture that underpin Ontology One. Without such transparency, it becomes challenging to compare its functionality to existing models or to evaluate the real-world implications of its neurosymbolic approach. Moreover, important metrics such as latency, cost performance, or accuracy benchmarks are conspicuously absent, which many in the industry consider critical for assessing viability. The potential trade-offs are noteworthy. The complexity involved in integrating a neurosymbolic system into existing e-commerce infrastructures might complicate adoption. If Ontology One's reliance on accurate data is as stringent as suggested, its performance could falter in heterogeneous data environments, possibly negating its purported efficiency benefits. A prudent path for interested stakeholders might involve closely monitoring Onton's further communications and seeking insights from peer-reviewed publications on neurosymbolic AI developments. Investigating ongoing research, such as explored in the TinyNS model, could offer valuable comparative observations. Should Ontology One's claims materialize into tangible results, it could significantly influence not only e-commerce search strategies, but may also extend its impact to various other sectors. Such an advancement could instigate shifts in product management strategies, academic research agendas, and even investment focuses within the AI landscape. However, until more concrete evidence and documentation emerge, the excitement surrounding Ontology One remains speculative at best. That's a wrap for today's Daily AI Brief. We explored Alibaba's Qwen 3.8 Max, Cogent AI's cybersecurity model VR1, and much more. Stay curious and keep coding. Tune in next time for more insights into the rapidly evolving AI landscape. Until then, keep innovating.